Here we are discussing the topic electricity for Edexcel IGCSE Physics examination. That too from the questions from the past 4 to 5 years of Edexcel board exams. In fact, this is the second part of the series and the link to the first part is given in the description box. Before we start, please like and share my videos and also subscribe to my channel. In fact, these videos are good for all exam boards because all exam boards cover the topic electricity and circuits. I shall show you how to answer them. So let us start with the first question in part 2. This is question number 7 because the other 6 questions are included in part 1. So it says about a toaster and it says that the toaster contains thin metal wires. It contains thin metal wires. Then the question is, give a reason why these metal wires are connected in parallel. So all the metal wires are connected in parallel. What is the reason? So when you have studied about the series and parallel circuits and the advantages and disadvantages of each of them, you studied that when the components are connected in parallel, even if one component or one appliance fails to break, all others will continue working. So let us put it as an answer. So here also, even if one wire breaks, the other wires get heated up and the toaster can function. So let us put it as an answer. When if one wire breaks, others will keep working. Now the next part of the question is state the formula linking power, current and voltage. So we have studied an equation, electric power. It is a product of current and voltage. That is, power is I times V. Those who are using the triangle method, and you know always at the bottom it is a product only, so I into V and the power will be here. Now next part of the question is the power rating of the toaster is 2.8 kilowatts. The power is given as 2.8 kilowatts. So 2.8 times, kilo means multiplying with 1000, which is in standard form it is 10 to the power of 3. So 2.8 times 10 to the power of 3 watts, and the voltage applied is 230. Now what you have to calculate is calculate the total current. So let us make use of the relation between current, voltage and power. We know that power is the product of voltage and current. Here we want to calculate I. So taking I as the subject, it's P over V, and the P is 2.8 10 to the power of 3 over the voltage is 230. So please make use of your calculator and it will give you an answer of 12.17 amperes. This is the circuit current. Now the next part is the toaster contains 48 thin metal wires. So already in the beginning they said there are metal wires connected parallel. So 48 wires are connected parallel means there are 48 branches. Okay, like this there are 48 branches are there. So the main current is branches out into 48. Now here calculate the current in each metal wire. So we have to calculate the current in each wire. So current in each wire is the total current, that is I over circuit I. CKT stands for circuit over 48, branches into 48. That is 12.17 over 48. Use your calculator and this will give you an answer of 0.25 amperes. So the answer is 48 wires means there are 48 branches. Each one is a branch. So in each branch, the current is total circuit current over 48. Now, a student investigates how current varies with the voltage for a metal filament lamp. Draw the diagram of the circuit that the student could use for this investigation. So this is an investigation question. It is coming from 2019 June. So he is studying the relationship between current and voltage. So definitely he needs an instrument to measure the current and also he needs an instrument to measure the voltage. So the instrument to measure the current, it is an ammeter. Also he needs to connect a voltmeter. Then the main component, that is the filament lamp. Please learn the symbols of all circuit components. And the energy source, it could be a cell or a battery. Energy source, and of course we need some connection wire. So let us bring them up as a circuit. So the battery or the cell, positive and negative, and we always connect the ammeter in series to the component or series to the circuit. Here we are studying about the current voltage relationship of the lamp. Then, okay, now student investigates how current varies with voltage. Varies with voltage means you have to connect a variable power supply also. So this is the symbol for a variable power supply. The inside line is not there. This is the symbol for a variable power supply. Okay, so the variable power supply, and now we have to connect the voltmeter across the lamp. So I didn't include the variable power supply here. Of course, we need a variable power supply to vary the voltage. So this is the symbol of a variable power supply. Now, why do we use the variable power supply here? What is the use of the variable power supply? Variable resistor. Sorry, it is not the power supply, variable resistor. Variable resistor is used to vary the current or the voltage across lamp. That is why we are using a variable resistor here. Now, describe a method the student could use for this investigation. So you have to write the steps. It's a 4-mark question, so at least 4 points you have to write. So adjust the variable resistor. So here we have a variable resistor. Adjust the variable resistor to get a convenient voltage across the lamp and measure the corresponding current. And repeat 2 to 3 times the measurement of current and take the average. This step we are doing to improve the accuracy. So let us put it as an answer. Step number 1. Step number 1. Adjust the variable. Adjust variable resistor. That is, we are adjusting the size of the variable resistor to get a convenient voltage across the lamp. Then measure the current, corresponding current 2 to 3 times and Find the average. Find the average of current. So this step we are doing to improve the accuracy. This is to improve accuracy. Measure the corresponding current. Now we want to study the variation of current for different voltages. So we are repeating this step 1. The whole thing is step 1. Adjust the variable resistor to get a voltage. Measure the current 2 to 3 times and find the average current. Then we are repeating this step 1. Repeat step 1 for another 5 to 6 voltages. Repeat step 1 for 5 to 6 voltages. This step we are doing by adjusting the variable resistor. That is by adjusting the size of the variable resistor and do the current measurements. That means you are just repeating it. Current measurements and averaging in each step or in each voltage. For each voltage, adjusting the variable power supply or adjusting the variable resistor and do the current measurements and averaging for each voltage. So now we have a set of voltages and the corresponding currents. So the next one is you can plot a graph of I versus V. Now the next one, now plot a graph of I versus V. Plotting a graph I versus V. Now as a next step, since it is a 4-mark questions, you have to include some safety measurement, safety precaution also. So as a safety, what we can do is switch off the circuit, in between readings. To avoid overheating of the wire. So these are the steps the student can use for his investigation. Now the next part of the question is, the student extends the investigation by recording additional data for the lab. So he has a set of voltages. This is what? Changing the voltage in steps, not the corresponding current, calculated the power and the energy calculations. So as we know, power is the product of, so we can write here power, it is the product of V and I. And then he calculated the energy. Energy, as we know, energy is power times T. Then he noted the color of the lamp. The question is, state the unit for current. Unit for current, it is ampere. Ampere, or you can just write it as A. Then calculate the missing value for the energy for the voltage of 4 volt. So this step, that is for 4 voltage, so you can see there is a blank, so you have to complete that. Calculate the missing value of energy. See, when we have studied about the equation for power, you studied that power is energy over time. So those who are putting this one in a triangle, you can see that. So energy will come here and energy over time. The balance is only power, so you can complete the triangle this way. Now if you want to calculate or if you want to know the equation for energy, so here they are asking about energy. Imagine this energy is covered. The rest of the equation is appearing as P times T. So we have the equation for energy. Energy is P times T, which is, so look at the table. For a 4 volt, the power is 3.6. So it is 3.6. Power is 3.6 watts times. The time is already given here. He switched the circuit for 45 seconds. So this is the time. So let us make use of that time also. It is 45 seconds. So 45 times 45. So please make use of your calculator to get the correct answer. So this will give an answer of 162. 162 joules. 162 joules. Now, the question is, give the answer to two significant figures. Here you can see there are three significant figures are here, 1, 6 and 2. So when you are writing into two significant figures, the answer value should not change. It should be in hundreds. At the same time, there should be only two significant figures. So we'll get it as 160 because the last zero doesn't have any value. Therefore, the correct answer is 160 joules. Now you have changed it into two significant figures. So this is the correct answer. Now the color of the star is related to its surface temperature. Sun is yellow. Identify the stars that are cooler than the sun. Identify that are cooler than the stars that are cooler than the sun. So as you know, the hottest star is white in color. So this is the hottest star. So our sun is here. So cooler than sun, it might be red or orange. So you can say the answer red or orange. Or orange. Now let's move on to the next question. Question number 9, this is coming from 20 June. The diagram shows a part of a circuit used for an outdoor lighting system. Look at the part B, give the name of the component. See, once the first part, it is already given the circuit symbol. If arrows are falling on the component, that means that shows a light is falling. Light is falling means this component is depending on the light intensity falling on it. The resistance of this component is depending on the light intensity. And we know that that component is light dependent resistor LDR. Then before that, draw a voltmeter to measure the voltage of the 4500 ohm resistor. As we know, we are connecting a voltmeter always parallel. So this is the voltmeter position connected parallel to 4500. You can even write that the voltmeter is connected parallel to voltmeter connected parallel. 4500 ohm resistor. Now part C, the voltage across the component is 3 volt. X, voltage across the component X is 3 volt. Calculate the voltage across the 4005 ohm resistor. So it says that I am going to represent the voltage across this component as VLDR. VLDR means it is the voltage drop across LDR. And this V only they are asking, calculate the voltmeter reading or voltage across 4500. And also it is the cell is providing 12 volt. Now you can see that the component X and 4500 ohm resistor, they are connected in series. Therefore, the supply voltage is divided among these two components. So we can say the cell voltage, the voltage of the cell, it is the sum of the voltage of the LDR and the sum of the, the voltage of the resistor. So now we have to calculate the voltage of the resistor, which is V of the cell minus V of the LDR. It says cell voltage is 12 and the LDR voltage is 3. So the balance 9 volt. So that is the voltage across the 4500 ohm resistor. Now next part is calculate the current in the circuit. Calculate the current in the circuit. So the circuit current, total circuit current. How much is the total circuit current? Now here you can see to measure the total circuit current from Ohm's law, V is equal to I times R. Therefore, I is equal to V over R. This is the way only we calculate the current. So here if you want to measure the total circuit current, the given voltage over the total resistance. But we don't know what is the total resistance, but we know one thing, the same current is flowing even through the 4500 ohm resistor and the LDR. So here also the current value is the same. So I can calculate what is the current flowing through the resistor because I know what is the resistance and I know what is the voltage. I already calculated it is 9 volt. So since both voltage of the resistor and the current through the resistor are known, I can calculate voltage of the resistor and the resistance value are known. I can calculate what is the current flowing through the resistor. Okay, so they have given you the equation already. V equals I times R. So here V of the resistor, I'm going to calculate from the resistance part. V of resistor is the current flowing times its resistance R. Therefore, I is V of the resistor R over resistance, which is 9 over 4500. Use your calculator. This will give an answer of 2 times 10 to the power of negative 3 amperes. This is the current flow through the resistor, or it is the current flow through the circuit. The main circuit current itself is 210 to the power of negative 3 amperes. Now calculate the resistance of the component X. Give your answer in kilo ohms. Now again, calculate the resistance. Here also I can use the Ohm's law equation V equals I times R. Now for this is for the component X, that is for the LDR. So you have to take the LDR voltage, which is the same current is flowing times the resistance of the LDR. Calculate the resistance of the LDR. So R times R LDR, R times I. Since we want to calculate the resistance of the LDR, put it as the subject. So it is voltage of the LDR times the current. And the voltage of the LDR is, it's given as 3. It says that 3 volt. Okay, 3 over the current is 2 times 10 to the power of negative 3. And this will give an answer 1.5 times 10 to the power of 3 ohms. but they want the answer in kilo ohms. They want the answer in kilo ohms. Kilo means dividing by 1000. So this will give an answer of 1.5 kilo, 1.5 kilo ohms. Now let's see the next part of the question. Explain where a lamp should be connected in the circuit so that the voltage across it increases as the light received by the component X decreases. The question is where to connect a lamp. Where to connect a lamp so that the voltage across the lamp should increase. The voltage of the lamp should increase when the light received by the component X decreases. Light received by the component X decreases. So when we have studied about the LDR, we studied that the resistance of the LDR is inversely proportional to the light intensity falling on it. Light intensity falling on it. So LDR resistance inversely proportional to the light intensity. That means when the light received decreases. So let us start from there. When light received decreases, I am using the symbol to save time, but please try to put the complete words and sentences. When light received decreases, what is happening to the LDR? The LDR resistance of the LDR will increase because this is the property it says. They are inversely proportional. And as you know, when the resistance of the LDR is increasing, the voltage drop across the LDR will increase because the same current is flowing. So we can say when the resistance is increasing, the voltage drop across the LDR will increase. This is according to Ohm's law, and also here the current remains constant. So I am writing current same, current remains same. So when current remains same, so we have the equation, actually we have the equation Ohm's law, V is equal to I times R. Since current is the same, as resistance increases, the voltage has to increase to keep the current the same, the fixed value, current same. This is what I have written here. When the resistance of the LDR increases, the voltage of the LDR increases. So we have to connect. So connect bulb or the lamp parallel to the LDR. Parallel to the LDR. So it is like we have the LDR, the light is falling on it, and you have to connect your lamp parallel to the LDR this way, such that if there is an increase of voltage of the LDR, when the LDR voltage increases, the lamp will get the same increased, lamp will also show the same increased voltage. This is because these two are connected parallel. In parallel branches, the voltage is the same. So the increased voltage of the LDR will be same as the voltage of the lamp. So the final answer is, so connect the lamp parallel to the LDR. This is the answer. Now let's try the next question, 10. Again, it's a circuit given, 240 fixed resistor and another unknown fixed resistor. The question is calculate the voltage across the resistor. Calculate the voltage across the resistor. Okay. Again, you can see that So voltage across the unknown resistor. So let me write it as VR, voltage across the unknown resistor, and this is the voltage across the 240 ohm resistor, representing voltage across the 240 ohm resistor. So we can see one thing, again it is a series connection, therefore the cell voltage, which is 9.2, is divided among these two resistors because they are connected in series. So we know that the voltage of the cell is equal to voltage of the 240 ohm resistor plus the voltage drop across the unknown resistor VR. So cell voltage is given. We want to calculate this number. So first of all, we have to calculate how much is voltage. So voltage across 240 ohm resistor, and we know that it is the product of Ohm's law, current and resistance, which is, the resistance is 240 and the current is given 12 milliampere. We cannot use milliamp, ampere is the SI unit. So we have to convert this 12 milliampere to ampere. So let us see. So 12 milliampere is equivalent to 12 by 1000 amperes. 12 by 1000 is 12 by 10 to the power of 3. So this is equivalent to 12 times 10 to the power of negative 3 amperes. So it is simple. Remember always, when you want to convert from milliampere to ampere, instead of dividing, you just multiply with the 10 to the power of negative 3. So this much is the current in amperes. So let us calculate it here. I is 12 times 10 to the power of negative 3 times the resistance is 240, and this is giving an answer of, please use your calculator, this is giving an answer of 2.8 volt. Now from our first equation, let us write what is the value of VR. VR is the voltage of the cell minus voltage of the resistor 240, that means 12 minus 2.8. This will give an answer of 6.4 volt. So this is the voltage drop across the fixed resistor R. Now the next part is a lamp with a power of 6.5 watts is connected to 230 voltage supply. Calculate the current in the lamp. We have already studied the relation connecting the power. We have already seen it is I times V. So here calculating current, so I as a subject, it is P over V, and the P is, it is a direct question, P is 6.5 over 230, 6.5 divided by 230. Please make use of your calculator. Check the answer, 0.28, which is approximately 0.03 amps. This is the current. Now let's see the next part of the question. The three switches S1, S2, S3 are used to control a lamp in a large room. And they are telling when all the three switches are up, the lamp is on. When all the three switches are up, the lamp is on. When all of them are down, the lamp is off. And here they are showing the on position. This is on position and this is the off position of the lamp or the bulb. See, each time they are showing what is the meaning of switch S1 up, switch S2 up, switch S3 up. So this pattern you have to follow here also. Now here the question is, you have to fill the table. So let me just complete this position of the switch here in the table. The first switch is up means it is right up. S2 is up means it is like a parallel appearance. Then switch S3 up means it is up leftward. This is what I'm telling, upward, this one. Now similarly, so they are telling that these two positions on and off. Then the switch S1 is down means it is left down. S2 down means it is somewhat like the crossed, like a crossed position. See, you can see it here. This is the one. Then S3 down means it is down left. Now the bulb is off. If so, please follow this pattern. Use the same pattern. Then it says that in this three situations only we have to answer. So in the first case, switch is up means it should be up rightward. It is parallel. Second switch up means it is like parallel. And the third switch down means it should be like this. Okay, now let us draw it here and see. Let us draw it here and see. This is up. Now, if current is flowing, it can pass through the upper parallel part S2. So there is a continuous path like this. Okay, but how is switch 3? Switch 3 is coming down only. Therefore, there is no continuous path of current, or here there is an open produced. There is a gap produced. Therefore, current cannot flow. So the lamp will be in off position. The next one is switch S1 is down. Switch S1 is down means it is down left. So it is like this, down left. And this is up means again it is like a parallel appearance. Now here you have to find out what should be the position of switch S3, up or down, and also the lamp should be in off position. So let us complete here and see. This switch is down. So if a current is flowing through the switch S1, then the next switch is like parallel. That means through the bottom the current can flow, and to continue this current, the switch S3, so lamp should be off means it should not continue. It should not continue means one gap must be here. So for that, S3 should be up like this. Then the current cannot flow continuously. There is no current flow through the circuit. So the lamp is off. So therefore, for this to happen, S3 should be up. So this is S1, this is S2, and this is S3. And in the previous case, S1, S2, S3 are given there. Now the third part is S1 is up, that means left up. S3 is down. Now you have to get the lamp on. Lamp on means, let us draw it and see. Switch S1 up. If current is flowing like this way, lamp should be on. Lamp should be on means there should be a continuous path here like this. So that means S2 should be parallel position means it should be up. And S3 is down. S3 is No, here you have to get it up, no? So it should be up and S3 down, S3 down. But if it is this position, it will not, current flow won't be there. Therefore, this is not the position. The position should be cross like this. The position should be cross. Then what is happening? The current S1 can flow through this way and it can reach here and it can make a continuous current flow. So S2 should be cross. This one, S2 should be cross. The position must be cross position of S2 means it is down. Cross position is down. See, this is the cross position. So if it is straight, parallel way, the current can flow, but since S3 is down, it cannot make a continuous current flow. Therefore, it should be down. Follow the pattern of S1 up, S2 up, S3 up, and also their down positions. Now the photograph shows an electrical appliance called a toaster. It says there is a power of 1800 watts and there's a voltage of 230. State the equation linking power. This is a repeated question. Power is the product of current and voltage. Current and voltage. Second part is show the current in the toaster. Show that the current is 8 amperes. Show that means your answer must be this number. So let us start with the equation. Power is current times voltage. We are going to calculate the current, which is P over V, and P is 1800 over 230. Please make use of your calculator to get the answer. So this is giving an answer of 8 amperes. Please make use of your calculator. 1800 so let me calculate the number. It is 1800 over 230. This is giving an answer of 7.82. Current is 7.82. .82 amps, which is approximately 8 amps. This is what is expected. So the current is about 8 amperes. Now the question is, which fuse rating should be used for the toaster? This type of a question was there even in part 1 of this video. So you know the fuse is used to protect the appliance. So there is a fuse wire. When a higher current is flowing, the fuse wire melts, makes a gap and prevents the current flow. So therefore, always when you are choosing the fuse wire, please remember the fuse current rating. Fuse current rating or the current rating of the fuse. Current rating of fuse. Current rating of the fuse, it should be little higher than the circuit current. I am using the symbol CKT for the circuit. So please remember this. Okay. So in this question, the circuit current is 8 amperes. Therefore, your fuse should be greater than 8. So 1A, 3A, 7A, they are lesser. So therefore, the possible answer is 13 ampere. So 13 ampere greater than 8 amps. Therefore, you can choose 13 ampere fuse here. Now the next part is the toaster uses mains electricity. Mains electricity provides an alternating voltage. Describe the difference between alternating voltage AC and the direct current DC. So let us see what is the meaning of alternating current. So alternating current is altering, continuously changing its direction. So alternating current, it is continuously changing alternating current is continuously changing its direction. So it will be changing its direction continuously like this. Whereas DC, direct current, so it does not change its direction, or it flows only in one direction. It flows only in one direction. Does not change its direction. So it flows like this. The next part is state a source of direct current, DC. So the current what we are getting from a cell or a battery, it is an example of a direct current. So from cell or battery, the current what we are getting from cell or battery is a direct current. It's a source they are asking, so no need to write this from. So it is a cell or a battery. Now the diagram shows an incomplete circuit. Draw the thermistor. See, we have seen many questions with the circuit symbols, either to draw the circuit symbol or to identify the component. So make sure you learn all the circuit symbols. So a thermistor, it is like a simple fixed resistor with Z. So this is the symbol of the thermistor. Add a voltmeter to the circuit to measure the voltage across the lamp. This is the lamp. So we are connecting a voltmeter across or parallel to the lamp. Voltmeter connected parallel to the lamp. Voltmeter connected parallel. Next part is the completed circuit is moved from a cold room to a hot room. Explain how this would affect the brightness of the lamp. Brightness of the lamp. You know, the brightness of the lamp is depending on the current flowing through it. Now it is moved from a cold room to a hot room. Moved from cold room to a hot room. And this is a thermistor. We know the property of a thermistor. The resistance of the thermistor is inversely proportional to the temperature. This is a property. So here when we are moving it to a hot room, so let us start the answer. In a hot room, that means when you are moving into a hot room, the first thing is the temperature increases. T stands for temperature. Temperature, hot room, the temperature is more. Therefore, the resistance of the thermistor decreases from this property. And when the temperature of the thermistor decreases, resistance decreases means the circuit current, I circuit increases, current increases. Current increases, so here I am writing the current increases. When the resistance is less, the current increases. So brightness of lamp increases. This is what is happening. Now next part is state how the current in the circuit would change if another lamp is added in series. Suppose one more lamp is added in series. So now already one is there. They are telling that say one more lamp is added in series like this. Okay, say R is the resistance. So when two bulbs are there, the total resistance is increasing. So R total increases, and I current of the circuit decreases. Current of the circuit decreases. So brightness. Now they are asking only the current, so no need of the brightness. The current in the circuit would change. So R total increases, so the current is decreasing. It's just one mark question. So you can write it as sentence: current, circuit current decreases. Now the next question is student given. This is a question from 2018 June, but this type of questions can be asked even now also because the concepts are the same. So it says from putty cylinders are made, different sizes, thin ones and little more thick ones and all. Usually we know the cross-sectional area of cylinders. It is a circular shape, circle. Okay, so it is easy to measure the diameter, diametrically opposite. If you measure the diameter at any two diametrically opposite positions, this is a circle, the diameter is the same, circular shape. But here you can see it is not having a regular circular shape. It is little irregular circular. Therefore, if you measure the diameter at different positions, it will be different. That is why they are asking you, the diagram shows the cross-sectional area of one of the cylinder. Use the diagram to determine the mean diameter of the cylinder, mean diameter, because it is not regular circular, it is little irregular circular. So we have to measure the diameter between two diametrically opposite points at 3 positions. So as an example, I am measuring it here, say D1, then I am measuring at this point, I am taking it as D2, then between these these 2 points I am measuring it, I am calling it as D3. You can see the length is different, diameters are different. Okay, so D1, D3, and let me write this as D2. This is D2. So the D average is D1 plus D2 plus D3 over 3 because there are 3 measurements. So for me, when I measured, I got it as 4.5, 4 and 3.5. And please make use of your ruler and measure it and then calculate. 4, 3.5, 3.5 over 3, I'm getting the number as 3.6 diameter, 3.6 centimeters. You may get a value between 3.5 to 4, 3.5 to 4 centimeter, it is accepted. So I'm getting it as 3 point. Make use of your ruler and measure it and calculate the average. Now coming to the next part, in fact this answer I have to write it here. I'm getting an answer of 3.6 centimeter. Now calculate the cross-sectional area of the cylinder of putty in centimeter square, and you can use the equation area equals pi times r square. And you know, radius is half of diameter. This is diameter. So here it is, say 3.6 over 2, it is coming as 1.8 centimeter. So I am using it here, pi times 1.8 square. Please make use of your calculator to get the answer. It's coming around 42.6, 42. Sorry, let us calculate it. It's not 42. It is pi times 1.8 the whole square. It is giving the value 11.17. So this is giving an answer of 11.17 centimeter square. Okay. So we can write the cross-sectional areas here, 11.17. And please, this cross-sectional area also depends on the average diameter you are getting. So redo the question, you measure the diameter and follow the steps. So it is giving 11.17 centimeter square. Now the next part of the question is, one of the putty cylinder is connected to a battery, and he measures the voltage of the cylinder and the current in the circuit. He measures the voltage and the current. Complete a circuit diagram. So a part of it is already done for you. This is the battery. Now we need an ammeter to measure the current. Then we are not varying the voltage here, so there is no need of the variable resistor. And we need a voltmeter to measure the voltage, voltmeter V, voltmeter to measure the voltage. So symbol for voltmeter is V, voltmeter to measure the voltage. Now the student uses the student uses his voltage and current measurement to calculate the resistance of the cylinder. He repeats it, and here they are asking you calculate the resistance of the cylinder. This question, resistance of the cylinder when the cross-sectional area is this one. For this value, calculate the resistance here. And we know that from Ohm's law, V is equal to I times R. Therefore, resistance is V over I, and I am using the same equation here. So, resistance equals V over I, and I have the value of voltage and I have the value of resistance, current. What is the voltage? It is 4.56 over 0.107. So on calculation, please make use of your calculator. It is giving an answer of 42.61. But they need for 3 significant figures. See, mine is now, it is 4 significant figures. Therefore, the answer is 42.6. So it is 3 SF, 3 significant figures. This much ohms. This is the answer. So let us write it here, 42.6 ohms for 3 significant figures. So this is the unit. Ohm is the unit, and this is 3 significant figures. Now the next part of the question is, when the student extends his investigation by connecting 2 new identical cylinders to a battery, the diagram shows the circuit he uses. The question is, he measures the voltage of each cylinder. Compare the voltage of each cylinder and the current. Comparing the current and the voltage when only one cylinder is used or when two cylinders are used. So let us separate it like this. So first part is as shown in the figure, the first one, two cylinders. Two cylinders are there. The next one, one cylinder. Okay. Let us assume that R is the resistance of each cylinder. They said it is identical cylinder, so R is the resistance of each cylinder. So first thing is about the resistance. So resistance total. This will be R by 2. This is for this one I'm giving an explanation here. When you have connected the parallel combination, the total resistance parallel circuit. In parallel circuit, the total resistance is the sum, one reciprocal of total resistance is the sum of the reciprocals of the individual resistors R plus R. They are identical. So on calculation, you will get this RT as R over 2. So this is why I wrote it as R over 2 here. When two cylinders are identical cylinders, resistors connected parallel, the total resistance is half of the individual value. Individual value is R, so here it is R over 2. Then let us see what is the voltage. Voltage across each cylinder. Voltage of each cylinder. Again you can see that the cylinders are connected parallel. Therefore voltage of each cylinder will be same as the battery voltage. So here is the battery. V battery voltage. Suppose this is 10, each one will get 10 voltage, 10 voltage. Then the next one, let us see about the current, because they are asking about the current and voltage. So the current is battery voltage. Each one is having the battery voltage. So voltage over resistance is R by 2. So this will give an answer 2 times V battery over R. This is what we are getting. Now let us see when it is only one cylinder. One cylinder means the total resistance is the same resistance, that is only one cylinder, it is R. Then voltage of that cylinder, it will be same as the battery voltage, V of the battery, because there is only one component, battery voltage. Now what about the current? In this case, the current will be, so the current is V battery over the resistance. So it is just a V battery over resistance. But look here, here it is 2 times V battery by resistor. That means current in the second circuit, that is with the one cylinder, it halved. So this is the conclusion we can write. So the conclusion, current is halved. But what about the voltage? See, the voltage remains the same. Voltage of each cylinder, whether it is one cylinder or two cylinder, it is the same battery voltage only. So it remains the same. So I can say the current is halved, but the voltage. So let us write about the voltage also. The voltage remains the same. Voltage remains the same, but the current is halved. So this is the answer. Current is halved and the voltage remains the same. The two answers. This is what they are asking, the comparison. Now let's come to the graph, the last part. Here you see that a set of values are given, cross-sectional area, voltage and resistance. And of course, we have to write the value here also. I forgot to write it here. So it should be 42.6, 42.6. Now to make the things quicker, I copied the cross-sectional area and resistance here because they want a graph of cross-sectional area and resistance. So I just copied it here to make the things quicker. So we have a cross-sectional area here, cross-sectional area, and this is the resistance, A and R. And they want a graph with the resistance on the y-axis and cross-sectional area on the x-axis. So first step is, while doing the graphs, the first step is label the x and y axis with the proper unit. This is our x-axis, and they want on the x-axis the resistance. So I'm writing resistance. Resistance in ohm unit. And on the y-axis, it is, resistance on the y-axis, and this is cross-sectional area. So here it is area with the centimeter square, cross-sectional area, and here it is resistance. So on the y-axis, it's resistance with the unit of ohms. Now let us mark the values. Before marking, let us have a proper scale for marking these numbers. You can see that the cross-sectional area, that is on the x-axis, it is varying from 4.5 to 24.6. Therefore, let us mark this as 5. Then this is 10. This is 15. Next one is 20. 25. You can go up to 30 because we need actually 24.5 only. The next one on the y-axis, it is changing from 48.5 till 91. That means at least 100, till 100 we have to mark. So I think we can mark it as each line, each box is 20, it's 40, 60, 80, 100, and it can go up to 120. Now the next one, let us try to mark the numbers. It is first one for 4.5, it is 91.2. 4.5, it is 91.2. So where is 4.5 on the x? You can see that on the x-axis, 5. That means 10 divisions. Within this 5, there are 10 divisions. Therefore, 1 division is, so within 5, 10 divisions. Therefore, how much is 1 division? So 1 division will be 5 over 10, which is 0.5. This is the calculation. So 1 division is 0.5. So where can I mark 4.5? 4.5 is before 5, because 4, it should be like 0.5, 1, 1.5, 2, 2.5, like that. So 4.5 will be the line just before 5. So 4.5 and 91.2. Where is 91.2? 91.2 will be less than 100. 91.2. So on y-axis, 20 ohms, there are 10 small squares, 10 divisions. So it is, each one is 0.2. So 0.2, 80, 82, 84, 86, 88, 90, 92. So it will be somewhere here. Next one is 6.2 and 77.3. 6.2 will be very close to 6.5, because here I cannot take 6.2 exactly. I can go to 6.2. So 6.2 will be the next line, and it is with the 77.3. 77.3 will be after 70 somewhere here. The next one 9.1. 9.1. 9.1 is before 10. So 9.1, 9.1 and 67.1. 67.1 will be 60, 67, it will be here, 67. Next is 13.9. 13.9, it is before 15, 13, that is approximately 14. 14 and 53.6. 14 and 53.6. 53.6 will be somewhere here. 50, 40, 50, 53. So it is 53.6. Then 18.1. 18.1. 18 and 48.5. 48.5 is somewhere here. And last one is 24.6. 24.6, but we didn't write the last number what we calculated. It is, the number is 42.6. So let me add that also, 42.6. 42.6. So 24.6, where is 24? 24.6 and 42.6. 42.6 will be very close to 48.5. It is somewhere here, 42.6. So this is the graphs, this is the lines or the points plotted. Now the next one is draw the curve of best fit. Curve of best fit means judged by your eye. So joining them and draw the line. This is the curve of best fit we are getting.